Today we're going to talk about bases, and I want to start off with what's at the top of the sheet there, dealing with strong bases behaving the same way that strong acids do, and that they dissociate 100%. Now, you already know the 6 strong acids. What are they?
HCl, HBr, HBI.
Yeah, so it's the chlorine, bromine, and iodine. Those are the 3 elements. And then the polyatomics are nitrate, so nitric acid, perchlorate, so perchloric acid, and sulfate, so sulfuric acid. Nice. All right, so strong bases do have an OH at the end, and it's based on solubility rules for hydroxides. So what are the solubility rules for hydroxides?
They're non-soluble.
It is soluble with ammonia.
Except with
Calcium,
barium.
ammonium. We're getting them all
1A
right.
It's
and H4 calcium on down.
good. So with hydroxide, nothing soluble except for group 1A and ammonium and calcium on down. Okay. Now, obviously, radium is not in part of the equation, but we'll never do anything with radium. So the strong bases are, they end in hydroxide and they have a group 1A or calcium on down. The bad news is when you look at a acid, it has hydrogen at the front. How do you know if you're looking at a base? It has what? Does not. Not always. But it has what? Always at the end. So if I'm looking at a compound, okay? And the R just means the rest of the equation. You'll do that a lot in organic. If I have an H at the beginning, I'm looking at a acid. If I have an H at the end, then I have a base. So what if I have it on both? Then I need to give you either a Ka value or a Kb value. Okay. However, if you just have a hydrogen at the end, you have a base. Okay. Is that cool? But if you have both, then I need to tell you. Now, I won't come out and say, hey, this is an acid, but I will cryptically.
Okay.
All right. Now, if this doesn't have an OH and basic solutions have hydroxide in them, how in the world do these make OH? Look at your sheet. Yeah. So it's what they do to water. In other words, if I have water in the reaction, actually let me write it correctly, HOH. If I have water in the equation, what it does is it rips a hydrogen off and attaches itself, and we're left with what? OH. Okay, so we'll have our hydroxide from that and whatever we have here, and then it'll be more positive. Okay, so the way that a basic solution or a base makes the solution basic is by ripping hydrogen off. So this acts like a Bronsted-Lowry acid. This acts like a Bronsted-Lowry base because it accepts that hydrogen ion. So it's not, the hydroxide is not from here, but we actually get it from water. So we must show water in our balanced equation whenever we work these out. Also the Kb, looking at your equation sheet, I'm not really impressed by the way that it's given to you. On your equation sheet, it actually has HB at the top. Actually, let me put the OH in here first. I'm more of a fan of BH. Okay? The reason why is because whenever we add hydrogen to a base, we typically put it on the back end. Okay? So it doesn't really make a whole lot of sense to put it on the front, but either way, it still works out. So no harm, no foul. And then on the bottom here, we just have our base, whatever that is. What I do want you to recognize also is that the hydroxide is on top. Just like when we look at our Ka, the hydrogen is also on top. So we always want the hydrogen or the hydroxide in the numerator whenever we have an expression. And that'll be really important once we start working with buffers, which is still a little bit down the road. Yeah, Danielle?
So are you able to say that the same thing that was with equilibrium on the top for the product and the bottom of the reaction?
Oh, still products, absolutely. So that means that we want to make sure that this is always on the product side. Yeah. Yeah, that's actually a very good point. But just as a real quick check, if your OH is on the bottom, you did something wrong. And hopefully you wrote that correctly though. And guys, I hate to say it, but that's the lecture. So let's do some. I want you to recognize the question says calculate the pH. Can you calculate pH for a base?
Yes.
Yeah. Can we calculate pOH for an acid?
Yes.
Yeah. So it's okay. You alright, Sam? Alright, so we have a solution where we have ammonia, and I'm going to write water this way. What are my products here? If ammonia is a base.
Is it NH4?
Good, NH4, so add it to the back. And then, since we took the hydrogen off of here and put it there, OH, good. And the KB has a value of, what's that, 1.8 times 10 to the negative 5. Okay. And we start off with an initial concentration for the ammonia at 15. What's my concentration for the water? So, 0?
No.
Oh, wait, we don't want to do that. Dash. Water will always be a liquid whenever we do acids and bases. And we never want to have zeros on both sides of the arrow, or arrows. So, I wouldn't know how to solve it if there were 2 zeros on there. Alright, so we know that we're going to shift to the right. So we'll reduce it by x here since our coefficient's 1 here, and increase it by x, coefficient 1. Same thing with the hydroxide.
In acid base, generally do you not have coefficients?
Typically not. Yeah, I can think of a couple, but not many. Alright, so there's our ice chart. Let's write our expression. So we have our ammonium, and our hydroxide, over the ammonia. And let's plug in those values, so x and x. Do you guys want to use 5% rule?
Yes.
You can, since it doesn't say you can't. That's a later question. So 1.8.
And then you treat them will tell us when we can and can't.
It won't come out and say it, but if you're given a concentration at equilibrium, you may not use it. If you're given a pH or a pOH, that is a concentration for the hydrogen or hydroxide at equilibrium. So if you're ever given an amount for something at equilibrium, you can't use 5%. Alright, so let me keep going here. So x squared. And then x, take the square root of that. So 0.0164. And what does that represent? What does x represent that we care about? The OH, good. So the concentration of the hydroxide. So if we know the concentration of the hydroxide, can we find the pH? Yeah. I might want to find the pOH first, then subtract that from 14, knowing that this is on the equation sheet, pH plus pOH equals 14. And on the next one, I'll show you the really shortcut, but I'll do it longer here. So pOH, since I know the hydroxide concentrations, negative log of the OH. So negative log of 0.164. So 1.78 is my pOH, and then pH would be 14 minus my pOH. Doing it. Oh.
There it
So everybody good? Like that? All right, on the back side, I gave you that table. I think I just gave you that table more than anything else, just to show how the bases look and then the conjugate acid. So here's our base, here's our conjugate acid. And you're given Kb values for our bases. Is it possible to find a Ka value? If you know the Kb? Yeah, but that's a later discussion. So we'll talk about that a little bit later on. So really, the only reason why I gave you the table is to show you that, yeah, these are our bases, and that would be the conjugate acid because it gains the hydrogen from the water. So that's what that paragraph's all about. Try the last example on your own where it says calculate the pH of a 1 molar solution of methylamine, and then the Kb value. I shouldn't have given it to you. It's in the table. So the formula for the methylamine is given to you there. And do include your charges. What's Craig know? Yeah? Why? Good question, right?
Cool dude.
Right.
It sounded like that was one of the problems. Why?
Why? Alright, come right up on the mic. My love goes after. Story of my life. This is all gonna be cut. You don't have to worry about that.
I'm
always ready as well.
You desired my attention, but denied my affection.
What?
Yeah, we don't know either.
That's the
Poetry for
no,
your...
no, it's the what is that Winter Wings? No, it's one of the
Don't ask me.
it's Bumperman Sons. It's Bumperman.
Don't ask us.
Are you guys using 5% rule?
And
Good call. What's that? Yeah, that's what the next one is, the next problem. You're gonna love it. Yeah! And you'll get to see it on the quiz on Thursday.
dude, I have tons
Do we use put that many sixes on there?
It doesn't matter how many you put until the end. So when you give a pH or POH, always show 2 decimal places. pH and pH only care about decimal places. But while you're doing work, you can show as many places as you want. And what I did here was use the quicker way. I'm looking for pH. I know that I can take 14 minus the POH to get my pH. I also know that finding POH, I can take the negative log of the hydroxide concentration, which is right here. And then so 14 minus that. But if you need to show the calculation for the POH and then take 14 minus that, that's fine. All right, taking a look at the last example, we may not use the 5% rule here. Now, on a question like this, I would, on a quiz or test, this would be the only time that you'd ever have to use the quadratic equation, and it'll be given to you. Okay, I didn't write that. I don't know how to make my A's look like that. But I had a student wanted to write that. Like, okay, go for it. But One thing about the quadratic equation in chemistry, we never do the subtraction. Okay? So this solves for x, so we'll never have a negative value or a negative concentration. So really all we use is the plus. Okay? Don't find the negative. And if you have this calculator, somebody showed me something else. It does quadratic equations and it's sweet and fast. So I'll make a video on that too. What's that? No, actually, somebody else. It was like 15, 16 bucks. It's less than 20. But the quadratic, I'm like, whoa, that's pretty cool. I'll show you guys if you have that calculator. All right, so let's take a look at this. It says calculate the pH of a 0.0075 molar solution of diethylamine, and the formula is given there. And you're given a Kb. Now the reason why you cannot use the 5% rule, because the Kb is so high and the concentration is so low, that actually if we use the 5% rule or the method for the 5% rule, it'd give us 25% error. So that's bad. So we'll still work it the same way here. So C2H5 and reacts with water. So what are my products here? Good. With a +1 charge. And oops, there's a 2 there. And OH. And then I think I gave the KB 1.3. It's 10 to the negative 3.
How do you know that it reacts with water?
What's that? How do I know what?
That it's water.
If we have a base, that's the only way we're going to get hydroxide. So it has to react with water. Because where's the hydroxide at in the diethylamine here? There isn't one. So we have to get it from the water itself. And what it does is it rips that hydrogen off and puts it on the end. That's why we have an extra hydrogen there. Okay.
So it won't necessarily be at the, it will be at the end, you can't put it at the beginning.
Put
Can't
what?
do-
I'm sorry.
You can't do C2H5 2 times and H.
I don't think the graders are going to freak out where you put it. However, what you don't want to do is put it in the middle.
Yeah.
Either put it at the end or you put it at the beginning.
Yeah, you wouldn't be able to put it in the middle. 'Cause
Right.
then you would
Yeah, and how many are in organic? Is anybody in organic in here? Okay. So when you take organic, if you choose to take organic, you'll find out why you can't place it in the middle, because there's no room. But put it at the beginning or the end. All right, so we know that we have
Your organic, how much
the organic is like this in your ice charts and bases. So, and Vesper is all organic stuff, which is easy.
Quite comfortable.
Yeah. Told you, man. All right, so 0.00750 and dash out that. All right, so our KB, all right, and go ahead and plug in our values. 1.075. And that all equals 1.3. All right, so since we cannot use the 5% rule, actually let's multiply those both up there. So let me rewrite. So we've got x squared is 0.00750 times 1.30. Oh, I forgot somebody. Minus x. Take on it. It's hard to. Times. All right. So what this is telling us, we still have to multiply these two together and these two together. Okay, so let's do that. I'll do the tough one first. I'll impress you guys with my math prowess here. So 1.3 times 10 to the negative 3 times negative x. And then we need to add that to whatever 0.0075 times 1.3. So that's 9.75 times 10 to the negative 6. Okay, we need to get everybody to the same side, so let's take these two and subtract it and put it on the other side. So, let's do this. So x squared plus, I'm going to change the sign, plus 1.30 times 10 to the negative 3, and then that sign goes to a negative, and that's all equal to what? 0. Very good. All right. So using the quadratic equation, okay, this is A, this is B, that is C. Okay? And let me scoot that over. So using this equation, we'll get rid of the negative sign. So minus 1.30 times 10 to the negative 3, and we'll only add, and then 1.30 times 10 to the negative 3, square that puppy, minus 4 times, I guess if you want to do 1, that's fine, 9.75, negative 6, and that's all over 2 times 1. Now, I will say that with the TI, and I don't know why, it really has been giving troubles here. What's that? Oh, yeah, thank you. There's a negative sign in there, thank you. So this calculator, what I would recommend, do the top, hit equals, then divided by 2. Because I try to put it in the calculator for whatever reason, doesn't like the order of operation. So. What's that?
This one?
Yeah.
Has no order of operation at all.
Has no order of operation? All
It just goes right
calculators.
to left.
Oh. So it doesn't matter if you're adding or multiplying, it just does it as you type it? New calculator time. And again, this all equals x. And anybody get a value for x? What is it?
That's probably wrong.
Say it again. I didn't hear
No,
it.
it's probably
I like the 0.00.
4.
254?
No, 0.00. Oh. Okay, yes.
That should be the correct answer. And what does x represent for again? Did you get it? And that's a negative right there. Did you get it, Cole? Oh.
Same thing.
I got.
Get it?
Yeah.
Nice, Taylor. You're probably getting like 0.0018 something.
Oh, I'm gonna be wondering
I got
Point. Okay, say it again.
0.00.
negative.
No negatives. Throw the negative out. If you're getting a negative sign or a negative value, it's not here.
I didn't get
You
that.
probably did.
No, she lied.
Okay.
She lied.
Yeah, Ashley. Okay, we'll talk about the calculator here in a second. Okay, I'll help you. Don't worry. We got tons of time. But what does X represent here? The hydroxide, right? So to find pH, I'm going to do 14 minus the POH again. Don't get negative numbers.
I'm getting 0.017.
like 11.40. Go up a little higher. Okay. And I'll come around and look at everybody's calculator here. I'm going to show you something new here. I'm using the Elmo, and I want to show you how to use the Casio, the FX115ES, by inputting these values in pretty quickly for the quadratic equation. And this calculator is really neat because it's not a graphing calculator. It's a calculator typically under $20 that you can get at either Target, Walmart, Kmart, wherever. And here's what we had for our last problem that we worked where you had to use a quadratic equation. So you can still input these values into the quadratic equation and solve, but this calculator, the Casio, is able to process all of these values for you and calculate X. So here's A, here's B, and here's C. So looking at the values, what we want to do is, so we start our calculator off looking just like this, and I want to try to get so there's no glare. When we start off, what we'll do is hopefully your calculator's in its regular mode. What we want to do is we want to change the mode or the setup. So you'll click on the button that says Mode Setup. And then what we want to do is click number 5 for equation. So click 5. And then it gives you different options for what type of equation. And number 3 has ax squared plus bx plus c equals 0. That's the one you want. So you'll click 3. So you'll choose 3 on your keyboard here. And then it gives you this option. It kind of looks kind of simplistic, but we're going to input our values here. So a is x squared. Well, the value in front of that's 1, so you type in 1. And then hit equal on your calculator, and it puts that value right up in top here. Doesn't show it as cleanly, but there's a 1 there. Now we're going to plug in the value for b, which we had for b was 1.3 times 10 to the negative 3. So we'll type that in here. So 1.3 times 10 to the negative 3. And then hit equal again. And then you'll notice that that value is placed in for b. Now we'll do it for c. And c in this case was negative 9.75 times 10 to the negative 6. So we'll go, negative 9.75 times 10 to the negative 6. Input that in, and you'll notice that that value is now in for C. So now we have the values in for A, B, and C in our quadratic equation. We need to hit the equal sign one more time. And it takes a second or two, but it gives us our first value, x1. And notice that this is our positive value, 0.0025, essentially 4. So that's the value that we actually want for our answer here. Let me scoot it over so you can actually see it. So that's our positive x, and that's the value that we want for chemistry because the x represents either your hydrogen or your hydroxide concentration. That's what we want. Now, if you're using this function for, say, other math classes, if you down arrow, it'll give you your second x value, which should be a negative sign. Okay? So I hope this feature is helpful.